The clips I shared with you, with your governor, I hope you've been able to watch it or go through it, because that will help us continue from where we stop. I didn't touch anything. I just kept everything intact. So everything the way from our last conversation, that's what we have here. I didn't touch anything. So drawing the network diagram has been taken care of by the grace of God. So I was somewhere around here the last time, and I was trying to tell you about how to calculate your EST, which is the earliest starting time, and also the earliest finishing time. And I was trying to give you my own personal approach to this. I was trying to say that for me, one fastest way to do that, when you have an activity, for example, activity A, I drew this circle here. I drew another node here, showing the beginning and the starting of activity A. Okay. And I said, if you are to look for the earliest starting time, I told you last week that the earliest starting time, when we say earliest, which is this E part, this E, is always all you have at I'm careful not to use the word numerator or denominator. What you have on the upper side of this called fraction. All the figures you have on this diagram, on the upper side of the diagram, is what you refer to as the earliest starting time and finishing time. Please mute your mic, please. Just mute your mic. So for activity A, again, mute your mic. If your mic, check if your mic is on or off. Everybody, look at your mic now and mute it. You are listening. You're supposed to know that they're asking you to mute your mic. You're not listening. Okay, so we say that for activity A, you have the first node 1 and node 2 showing your starting and your ending. Your starting and your ending of activity A. So I was saying that if you are looking for your starting times and finishing time, or the earliest, always look at the ones that are up. If you are looking for your latest finishing time, always look at the values that are down. That's just a long story about this, the upper and the lower values. So with that, you can be able to now calculate things. We talk about your total float, your free float, and also your independent float. And I explained the last time that when we say float, we are talking about the free time that is available to complete that activity. And let me give you an example. Somebody asked me, I think Daniel also last time, if you look at activity B, look at activity B here, for example, this B, activity B. So as I was saying, I said, if you take a look at B, activity B is supposed to take 3 months. But we are seeing here that its earliest finishing time is 6 months. So meaning that, and it is so because of activity D. Look at activity D. This is D and this is B. D and B are going to finish at the same time. So because D actually is, its own duration is even 4 months. But when we did the calculation here, we added 2 to 4, gave us 6. So we are looking at overall, D, it can still stop at 6. That's the earliest finishing time. Meaning that D has some spare time. For D, for example, D even have up to 2 months extra. For B, B has up to about 3 months extra. And that is what we refer to as the float. The extra time, the free time that you have to complete an activity. You can record now. You can record. So the spare time that you have to complete an activity. So now, when we talk about the float, last time I tried to give us the formula. I said for total float, which I think I have all of those things here. This is for total float. You have latest finish time minus what? Earliest starting time minus duration. This is float. Actually, this is supposed to be free float. This is free float. It's supposed to be free float. This is free float. Earliest finishing time minus earliest starting time minus duration. Then the independent float, you have earliest finishing time minus latest starting time minus duration. So the total float is the time that an activity can, the free time or the spare time an activity have, such that if it uses that time, it's not going to affect the overall completion of the project. That's what total float is about. And I try to give you an example here that if you are calculating for activity A, looking for total float for activity A, you know already that its earliest starting time is 0. You know that its latest starting time as well is 0. Then for the finishing time, you know that its earliest finishing time is 2. And its latest finishing time is also 2. So applying this formula here, total float equals to latest finishing time, which is these 2 here, this is the latest finishing time, minus earliest starting time, minus this 0 here. And that is why I gave you this arrow, that just bring this arrow this way. That means you are using this one, minus this one, then minus the duration. That will give you total float. So if you come to activity B, the same formula also applies. For activity B, look at B again very well. Activity B starts from here, this point here, and it ends here. Okay, so if you're looking for total float for activity B, how do you get it? You have to come down here, which is the latest finishing time, which is 7. 7 minus the earliest starting time, which is 0. Okay, then minus what? Minus the duration, this 3, minus 3, which will give you what? It will give you, this will give you 4. Okay, so total float for activity B is going to be 4. And so that's how you apply it for the other activities, one after the other. When you are done, you will get this table. You will get this table here. You will get a table looking like this. Okay, so for every activity, activity A, earliest starting time is 0. You have to pick all of this from the diagram that you drew. From the diagram that you drew, you'll be able to get what all of this represents. All of this is on the diagram. 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 This has been given to you originally. So what you are only calculating is just this one, and this one. Okay? If you go back to this diagram, every information you have on this column is on the diagram. Every information you have here as well is also on the diagram. The only thing you just do is to apply the formula that you have here, which I've given you here. Just apply this formula with this formula. You'll be able to get everything that you have to your total float, your free float, and your independent float. Is that clear, please? Hello?
Yes, sir.
Okay. So that is that for that. And that was how we arrived. We had this table. So in the examination, you will be asked to do this table. In fact, I'm not going to wait for the examination. I told your governor that next week I'll be coming to the class. I don't know how many of you are here now. I don't know if your governor is even here. Please and please. And how we'll do it, I don't know. But next week, it will be very important. I want you guys to be present. There might be a surprise test that might take place that next week. and it's not going to be outside what I'm showing you now. So at the end of today, I'm going to give your governor this material. So you have this material, you practice it. When I come to class, there's going to be a test on this. However, that test, you may not understand it so much. I will explain the beginning of the test for you. Then you finish it up with what I'm showing you. All right? Please and please, it's a handwritten test. Everybody will be there. I'm going to go with everything that you put down on Saturday.
All right.
So,
Okay, sir.
yes, so I will give you another example. Look at this, it's almost the same. There's nothing to worry about this. The appearance may look different, but it's more or less the same. Mrs. C. Ejekam, the CEO of blah, 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 has the following information concerning the various activities needed to accomplish our oil project. Now, you have activity 1 to 2 equals to 4 weeks. Activity 2 to 3. I like questions like this because at the end of the day, you might have, your diagrams may not be the same, but you must have the same answer, okay? Depending on how the nomenclature, the way you want to go about designing your diagram, you get the same answer at the end of the day. So you have activity 1 to 2 has a duration of 4 weeks, 2 to 3 has a duration of 2 weeks, down to activity where you have 5 to 8, which has a duration of 1 week. So you are required to draw a network diagram. You are required to draw a network diagram to represent the above information. And you are also required to identify the critical parts. You're also required to determine the minimum time required to complete the project. I believe by now this should not be a challenge to us. So, but notwithstanding, I'm going to start again so that this will just be like a refreshing to refresh your mind on what we did the last time. Now, we have activity 1 to 2, duration of what? 4 weeks. In this case, we don't have anything like A, B, C, D, and all the alphabet that we had before. So, like I said, it's more or less the same. So when you want to begin, I don't want to confuse you. Otherwise, if I was to do this, I will still look at, is there a relationship elsewhere among the activities? If you look very well, there must be some kind of relationship. From activity 1 to 2, you now see activity 2 to 3, okay? And then you see activity 3 to 5. You are seeing again activity 2 to 4. Already you've seen 2 to 3. This is 2 to 3. You're also seeing 2 to 4 again, telling you something about activity 2. There's something peculiar about it. When you look at, you have activity 1 to 2 here. You're also seeing activity 1 to 2 here. It's giving you an idea of what you should expect in the future as you begin to draw. You have activity 5 to 6. Activity 5 to 6 again is still coming up somewhere around here. It still is giving you an idea of what or how your diagram is going to look like. But notwithstanding, even if you don't understand that, just go ahead and draw based on the stage at which you are. You might have to clean when you realize that you are making mistakes. You have to, clean to readjust your diagram. So let's begin. You have your first node this way. You can give here node 1 to node, let me say this node 2. Which is our first activity 1 to 2. We have 4 days here. Next activity 2 to 3. This is telling you that the next activity is going to begin from here. It's going to start from 2. You don't know what's going to happen in the future, but let's move. This activity 2 to 3. Duration for that is 2 weeks. You have the next activity 3 to 5. Activity 3 to 5. Let's just draw. If we need to make adjustment later, we will make the adjustments. Activity 3 to 5. Let me stop here. And here becomes our 5. And then we have 3 weeks here. We are seeing activity 2 to 4. Mind you, if it's going to be 2 to 4, that means we have to come back to 2 and draw this here. Have this way. This become our 4. And how many weeks is this? This is 2 to 4 is 6 weeks. We have activity 1 to 6. We're coming back again to the beginning here. So if this is this way, and then we draw this way, this activity 6. No, 6 rather. 1 to 6, we have 2 weeks here. We have activity 5 to 6. Activity 5 to 6. So now, when you look at this very well, you realize that you might need to readjust your drawing. Okay, you might need to readjust your drawing so that you can have the link between 5 and 6.
Also,
So
yes.
you, if you say that, please mute yourself.
Daniel Dari, mute your mic now. Daniel Dari.
We can come here now. This is what I'm saying. That you might have to withdraw. So you come here now and let's put 5 this way. And then for 5 to 6, we have 5 weeks. So since we are having a connection between 5 to 6, right?
Yes.
So we have something like this. This is the diagram showing you the direction. Okay. And then we have, now watch. You begin to see why I say at the end of the day, you might have to readjust your diagram. You see what's happening now, that 4 seems to be standing alone. Activity 4 is standing alone. Okay. So, and we say that if you can't have such an activity standing that way. I'm happy I have drawn this, but I want you to see some of the mistakes that you can be making in case you're in the exam hall. All right. So, but the most important thing there is the direction. First of all, get the direction where we are going to. Okay. Get the direction. Now, we say the next we have activity, we have done 5 to 6. Now 4 to 5.
5.
4 to 5. So ordinarily, like I said, you cannot leave activity 4 that way. If we hadn't seen anything, though the table will tell you, somehow we'll then have to use maybe a dummy activity, or we take it outside. Take it outside means this might have to move from here to this way. Okay, so but as it is now, the table dictates that it is going to link to what? 5. So we have activity 4 to 5. So all we just do is to link this way. Sorry, let me withdraw. Let me leave it like this. For 4 to 5, we have 9 weeks. Then we have activity 6 to 7. So we can have something this way. 6 to 7 can come this way. Oh, this is a bit too long. Let me clean this a little bit. Yeah. Okay. So this is 7. And then we have 6 to 7 is 7 weeks. So we have activity 5 to 8. Activity 5 to 8. So
We have 7 to 8.
Yes?
7 to 8, sir. You
Okay.
7.
Okay. Oh, sorry. Activity 7 to 8. Thank you. Activity 7 to 8. So let's move this way.
Activity 5 to 6. The duration.
Thank you. Activity 5 to 6. The duration there is 5. Thank you.
Is not there. You're not.
Yes. So 7.
The duration.
7
But
to
sir,
8. We have this. Yes, please.
the activity 3 to 5. you put 5 weeks as the duration.
That's supposed to be 3. I think
Oh.
It's supposed to be 3 years.
yes. Let me rewrite it. Thank you for that. Okay. So 7 to 8, you have 10 weeks. And then you have what? The last one there, 5 to 8.
8.
Five to 8, you have 1 week. So there is no node open. Everything is closed. So everything ends at node 8. Node 8 is the last node here. Okay, your diagram can be different from this. That's why I say it depends on how you want to take the orientation. If I hadn't brought 6 backward, I can still move it a bit forward. It will still change the diagram in a way. But what matters is that at the end of the day, we must get to the same point. I gave you this. What I did before this class is different from this diagram. And the one I actually plan to give you is also different from this diagram. But everything is going to end up having the same answer. So quickly, let's see how we can, because of time now, let's see how we can begin our movement. So since we said, starting from here, this is 0, okay? 0 plus 4 will give us 4 here. Okay. 4 plus 2 will give us 6 here. Let me just be putting this in advance. Okay, so here we have 6 plus 3, which will give us 8. But because we are having 2 different activities, we just started now and I'm seeing running out of time. Why? We have 2 different activities. 6 plus 3 will give us 9 rather. Then we have nothing here yet. So let's come back here. Here you have 4 plus 6. 4 plus 6 will give us 10 for this one. So 10 plus 9 will give us what? 19 here. By convention, we said the one with the higher value is what you pick. So we are going to pick 19 here. And then we move. All right. So we can then make progress. Now we have 19 plus 1 will give us 20 here. Okay, but we can't move yet because we have some other activities before this. So let's come back to the beginning. Between node 1 and node 6, we have 0 plus 2, which will give us what? Which will give us 2 here. Okay, here we have, this is coming this way. Between node 5 and 6, you have 19 plus 5. We give you what?
Then 24.
24.
Sir.
24. So if that is the case, meaning that we can't use this here, because if you realize we have 2 arrows coming to 6. Okay, and we said the bigger one is what you pick. So here will be 24. All right, so if this is 24, we have 24 plus 7.
Sorry, sir. Please, how do you get the 24, sir? Sorry, sir. Sorry for taking it.
I said
19 plus
19 plus 5.
19 plus
From node 5 to node 6, 19 up here plus 5 will give you 24. I said because we have 2 activities written at node 6, we have to pick the one that gives us the higher value. So 24 plus 7 will give us what here? I think this should be 31.
31.
31. Okay. Now we have 31 plus 10 should give us 41. Obviously, we are going to pick 41 because 41 is higher than 19. So I said whatever you have here is what you put here. It becomes 41. What we have done, we have finished our forward pass forward pass is what we just did. And in forward pass, all you focus on is addition. And I said the addition, we are looking at the higher value. Now, going backward, you have 41 minus 1. This will give you,
40.
it will give you
40.
then 41 minus 10 will give you the same what? 31.
1.
Here you have 31 minus 7.
That's
Which will give you
24.
24.
24.
Will give you 24. Here you have the next. Let's come back up to note 5. At note 5, you have 40 minus 3. 40
That
minus
is 37.
37.
37.
37.
37. I hope you see this. 37. Okay. And from here as well, you have to use 40 minus 9. 40 minus 9 will give us
31.
31. Okay. So we also have, let me see, we have 40 from note 5 going to note 6. We have 40 minus 5 here.
Six.
Okay, we've done this already. So then 31 minus 6,
25.
25. That means between note 4 and note 2. Give us 25 there. I think something is wrong somewhere.
Yeah, sorry, sir.
Yes, we have.
When you said 9, you said 19 plus 5 is 24. The 2 earlier, I think it was not among the 24 then. It should be 26 with the 7, then the 10. 26 plus 17.
Which of the notes are you referring to now? You mean here?
What is that?
Are you saying this point here?
Yeah, I said 1 to 6, point 1 to 6, 2, then you said from the point 19, you added 19 with the 5 to being 24 to the point 6. I thought you were supposed to add the 2 with the 24 again to.
No, you don't add the 2 to 24. No. So we have yes, any other person that have figured out what is wrong here? Look at it very well. Look at it very, very well. There's a mistake somewhere. I want you to figure it out yourself now. Why are we having this issue? Our forward pass was excellent. Coming back is where we have the issue. What went wrong? You have very less minute now. Something is wrong. I don't want to point at the exact spot where it is wrong, but I want you to look at it critically. I hope you can see my handwriting. This is 6/37. How many people do we have here? Let me see. Okay, we have a good number. So what do you think is wrong with this? Where is the mistake coming from? Because these are some of the things you will see in the exam. Like I said, once you miss one step, it becomes an issue. I would have gone ahead to just give you straight, but I want us to work it together. And then since I ask you the figures, you give me figures, let's do it together. But now there's a hookup.
I'm in class. So what?
Please, can we
Anybody?
start again from the backward method if we can see the mistake?
Okay, that's an intelligent way to look at it. All right, we said 41, right?
Okay.
41
Yes.
minus 1
40.
give us 40 here at node 5. And then we had this 40 here. But let's look at it very, very well. Is it how it is supposed to be? Look at node 5. The problem is from node 5. Look at it very well. Look at node 5. The problem is from there.
Sir, I think. Hello, sir.
Yes, I'm with you.
I think from that node 5 to node 6,
Yes.
I think it should be 40 minus 5.
Why do you say 40 minus 5?
Yeah, because this node is joining to node 6. It should be 40 minus 5.
40 minus 5.
So which will give us the what?
Okay.
Sir?
Thank you for that observation. But take a close look. Node 5 that you are looking at, when you look at it, there are two activities that proceeded from node 5. Two activities. So when we are going back,
Yeah.
consider the two activities. So if you say 41 minus 1, it will give us 40 on node 5. But like I said, there are two activities on this node going back. So you also have to look at this as well. So here we have 24 here. 24 minus 5 will give us what? It will give us 19. And 19 is less than what? It's less than 40. So we have always established that the lower value is what we always pick when we are going back. All right? So this 40 doesn't need to come up at all. Why? Because when going back, we said there are two activities that lead us to node 5. The first activity says it's 41 minus 1, which is 40. Fine, we keep it aside. We'll look for any other activity again that is connected to this when going back. Activity 6 to 5 has 24, which will give us a lesser figure. If we say 24 minus 5, it gives us 90. So this 40 is not supposed to be here at all in the first place. All right. So
Okay, sir. Going back, you consider the lesser figure.
I said that last time. Yes. Going back is the lesser figure. Going forward is the higher figure. All right. So that's out of the way. I will still be watching. I might still do another one because I want you to figure it out as well. So let's see. Here we give us what now? We have 19 over 19 here. So that's taken care of around this point here as well. So now going back, if this is 19, we are going to 3. So 19 minus 3 will give us what now? 19 minus 3.
16.
Give us
16, sir.
Beautiful. So let me clean this off. So we have we had 6 before over 16. Over 16. Okay, 6 over 16. Good. That is out of the way. We come back to node 5. Node 5, we have 19. 19 minus 9. We are going between node 5 and 4. 19 minus 9 will give us what? Will give us 10.
10.
Good. So this my deleting now will roughen this thing, but we have 10 over 10 here. Okay, so take a look at it again between node 4 and node 2. Remember, take note. Node 2, you have I would have done this again, but because of time, let me just go straight. Node 2 have 2 activities proceeding from it. So if you have 16 on node 3 minus 2, it will give you 18. If you come back to node 4, 10 minus 6 will give you 4. 4 is less than less than 14. 16 minus 2 will give you 14. So 4 is less than 14. We pick 4 here. We put 4 here. So that is out of the way. And we have one last node left, which is the final one. Usually, it's always straightforward. What you have at the top must always be what you have at the bottom, but you have to work it out at this point. So the most meaningful, you also see that node 1 has 2 different activities. 4 minus 4 will give you 0. Fine, that settles it. The other one, you have 24 minus 2 will give you 22. So you pick this one. You have your 0 here. And that's the end of the story. That is the end of the story in terms of the diagram. But you see how it can be confusing when you are going back. So you have to be very careful. If I had chosen to withdraw the diagram such that, look at this same diagram is what you have here. It's what you have here. It's the same diagram. The same diagram. But you see that nomenclature is different. But at the end of the day, you arrive at the same thing. Okay, the same diagram. So most likely, I think I might test this in the exams, or Saturday anyway will determine what's going to happen on exam day. However, but take note, always watch for activities that are coming out from a node. Once it is 2 or more, then you have to be very careful, especially when you are going back. You have to be very careful. So you draw the diagram, identify the critical parts. Now, another thing I didn't touch so much the last time, there are various ways of doing this, which I like for myself. I have different ways of doing it. Now, I will show you the first way. If you want to get critical parts, sometimes we want to see the parts, all the parts, or the critical parts to the of the project. Okay, that means the completion time of the project. For example, if you look at this, let me use a different color. Let me take this, for example. If you start from node 1, to node 2, this way, node 1 to node 2, to node 3, to node 4, to node 5, I mean, and to node 8. This is one part to the end, which is 1 to 2, 2 to 3, 3 to 5, and 5 to 8. When you add it up, you will get a value here. You can also start from this 1, okay, to node 2, and then cut off this 3 and come to 4, and go to 5, and come to 8. Meaning, I'm saying from 1 to 2 to 4. I have to bring it back.
To 4 to 5.
Yes,
then 8.
Something has been cleaned. Yeah. So
1
to 2 to 4 to 5 and
to 6
to 8.
To 8.
1 to 2, 2 to 4, 4 to 5, 5 to 8. You add it up, you have a value here. Then you can also have the third leg. Now you can have from 1 to 6. Okay? 1 to 6. You can have from 6 now, you can have to 5. And then from 5, you can have to 8. This is another part. Okay? You can also have another part again from 1. I didn't mention this earlier on. You can have from 1
to
2, then
to 4
to 4, then
5
to 5, then to
6
to 6. Beautiful. Please, who is that person? 1 to 2 to
4
to 4,
to 5,
to 5,
to 6,
to 6,
to 7,
to 7,
to 8.
to 8. Now, by the time you add this, you realize that this one will give you your longest part, which ends as 41 weeks.
Weeks.
Bigger part. Okay, so I'm giving you all of this. Why I'm not so much bothered anymore, because I know that after now we'll still try and give you this recording. So that's why I said don't bother to ask me for recording. I will send this to you, to send it to your governor. You go through it again. In the exam, you might be asked to determine all the parts that leads to the completion of the project. Okay, and then you add up. But I know that the longest part, this is the longest part, and this is the most critical part. All right, that's how to determine that.
Hello, sir.
Yes, please.
So the first, what's it called? The first line
The first line, okay.
where you,
Yes.
where you
Yes.
were trying to from 1 to 2
To 3 to
then
5
to
to
3
8.
to 5 then
Yes.
to 8.
Yes.
This up here at node 3.
Uh-huh.
Yes, sir.
Yeah,
I think the what's it called? I think that place is not a critical. It's not a critical part.
I just said all the parts that lead from the beginning to the end. The critical part is the one we just discovered. This one.
Okay.
Hello,
The
Mr. Yeda.
41.
I will call you back, please. I'm in a class. Yeah. Okay, so that's that for that. I hope this is clear.
Yes, sir.
Yes.
So now you are
Yes.
asked to look for total float, independent float, and free float. All the explanation I gave you earlier on for this is what we are also going to apply. Is what you are going to apply here. So this material will be given to you this week. I'm urging you. I left this place blank. I left all of this blank. It's for you to fill this up. Fill it up with the information you have. Okay.
Okay, sir.
Diagram. You've seen all the necessary. Practice this. And then the next example we are going to look at now, or what we've been dealing on, we have been dealing on CPM. Now I want to talk about the PET, performance evaluation and review technique. There is nothing special here. Yes, please.
Sorry, back, but you kept talking about that diagram, though I'm joining somehow late. I wouldn't want to draw you back to recap on it, but then I don't know how we're going to get, because by the time I joined, you have gone that far. So I don't know how we're going to get material on this. And you made mention of it that it might appear into our exams. So I don't know how we are going to do it, but we actually need this diagram and how it is explained.
Were you here last week? Were you here last week?
I wasn't, sir.
That's why you're asking this. After that means you've not even seen the lecture we had for last week. The recording to your governor. So don't worry about how you get it. Like I said, I will give him this recording. I will also give him this material you're looking at. So it's not the ball will now be in your court. So it's now left for you to do the needful. I repeat, do.
Okay, sir.
All right. So now for performance evaluation and review technique, please. This one is also a sure banker. What you look at here, like I said, there's nothing different from what we've been discussing. The only difference is just the beginning, how you start it. I started my teaching 3 weeks ago that for this you have 3 different time estimates: the optimistic time, the most likely time, and the pessimistic time. So we say things. Oh my God. Hello, Mr. Kingsley. I will call you back. I'm in the class. I will call you back in the next 2 hours. So we have 3 most likely time. We have the optimistic time, the most likely, and the pessimistic time. So generally, I keep saying that when you are dealing on pets, your focus should be on how to collapse these 3 times and get your expected time. I don't know who is doing this tick, this good tick here. I gave you this formula and I explained this enough the last time. For example, you have for activity A, what is going to be our expected time, which is what you have here, TE. This is what this stands for. The expected time for activity A will simply be the optimistic time, which is 1, plus you have the most likely time, which is what? Is 3 times 4, because we said 4m. And then you have plus pessimistic time, which is 5. Okay? Everything divided by 6. So when you do your maths, you have 12 plus 1, 13, 13 plus 5 will give you what? 18. Am I correct? Divided by 6, this will give you 3. So what we are saying here, remaining minutes, let's continue what we have. Are we together, please?
Yes, sir.
Thank you very much. Thank you very much.
Yes, sir.
Okay, beautiful. So, like as I was saying, I said, just apply this formula that you have here. You have your 1, A plus 4m plus B divided by 6. And in this case, we say A is our optimistic time, which is 1. I think this is in hours. M is our most likely time, which is 3. And that's how we got this 3. This 4 you are seeing here is from this formula, 4 plus B. B is our pessimistic time. That means we think it will take longer than necessary. That's why you have 5. So we have our 5 here. When you do your maths, you will get 3. The same approach is what you will do to get the entire column here for your TE, which is your expected time of completing each activity. Okay, just apply the formula to get for all of these. You'll get that here. So when that is done, everything that I've taught you on CPM from the beginning is what you now begin to apply. You are going to just apply. Let me just show you. Let me show you. This is what you have. Okay, I've done that here already. So our expected time from the maths I just did, we had here as 3. When you do your maths here as well, applying that formula, you will get this figure here. So this is the column I was saying that you will get applying the formula. It is with this column now that you begin to draw your network diagram. You use this information. First of all, go back here. You see that these are the activities.
Sorry, sir, I can't really hear you from here.
Okay. Is anybody else having the same issue? Can you hear me?
No. I can hear you clearly.
Okay. So I'm tilting, bending close to my laptop. So I guess you should be able to hear me better now. So now we have, these are the activities and these are the preceding activities. This is telling you what is happening before any activity happens. Yes, Ngozi? Ngozi, go ahead.
Okay.
Yes.
When we got like these 3.66 now, let's say we have 3.7 or 3.5, can we approximate?
Well, you can, but at this stage, you can only approximate. For me, I will accept the approximation at your final answer. But at this point, when you are still working, just leave it this way.
Okay.
At
Oh,
least
we should not.
Yes,
Okay.
two decimal places, okay. 2 decimal places out.
Okay, sir.
Your final answer, well, you may approximate at that point. Okay, so
Okay, sir.
yes, with this now, this was how we got this. This was how we got this. Okay. So I will not explain much on this. You will have this, you will take this table and use it to practice what I've already taught you. You will see how we arrive here. The difference between what we have been doing and this one is just this beginning. Every other thing is the same. There's no that difference. It's just this formula. That's just the difference. Just this area where you have this formula. That's all. So you apply the same thing to get this particular table. I shouldn't have given you this, but I just want to save you the stress. Now take note of this. If you look at this, however, like I said the last time, the table will tell you you have drawn B now this way, and B ends here. There's nothing connecting with B, so B is standing here. But based on the table, this is supposed to be the last node. You cannot have two nodes open like this. It's not proper. But however, like I said, the table has helped you to tell you that B is going to meet somewhere here. B is going to meet at this point. That means B, C, and F, they are going to meet at a particular node. And that's what you have here. Look at it on this table. B, C, and F. So, like I said the last time, that how do you connect B to F? You use this dotted line, which we call dummy. This is just a dummy. It's not an activity per se. Or we refer to it has no time duration, no resources, anything. But it's just for us to complete this. B cannot stand alone as a node, an open node this way. So when that is done, then you have these tables. I've also done this for you, the dependent float and all the whole floats. All I just want you to do is to go and practice this. Okay. I also added something here because there's an aspect I'm thinking maybe if I come to class, that's when I will talk about that. There's one, if you look at this question, the questions that are here, I'm thinking I don't want to push you too far, but I think it won't be bad even if you know it now. When you get to master's level, that's what you do. So if you have that knowledge now, it's not bad. Now, you are asked to draw network diagrams. You are asked to determine critical paths, which are every other things you've been doing before. Now, there's one addition I'm thinking of adding, number 6. When I come to class, I think I will do that. You might be asked to look for the probability. Probability is another important aspect as well. This project, for example, when you look at it, the project based on this diagram, the completion time is roughly approximately 16 hours. Okay, you're having 15.99. This is the completion time. I can ask you in the exam that what is the probability of finishing this project either before 16 hours or after 16 hours. I can give you 18 hours, for example. So if that is the case, if you are asked, that is, if you are asked, you may not be asked, but in case you are asked to look for the probability of finishing this project within maybe 18 hours or so, or even less, all you need to do, you come back to this table. We have 2 ways of doing that. Maybe if I come to class, I will explain so that I don't over stress you with too much information. But I will just say it because it's on record so that when you go to play it, you can also learn. You have 2 options. You may have to create another column here. You may have to create another column here for something here. Look for your variance. Okay. And for variance, usually you say you are supposed to take the most time from the least time, the least expected time. Okay. So you have A minus B divided by 6 raised to the power 2. You still get the same figure, the same value. So you fill all of this. But a faster way to do this, if you don't have the time to start to work, because you don't need all of this, you don't need all of these columns, these rows. You may not need that. Your focus should be on whatever you've discovered as your critical part. For example, when I give you this material now, you realize that the critical part for this part is from E here to F, E to F, and then to D. These are our critical parts, E, F, and D. So when you come to this table, you just focus on the columns or the rows rather. That has to do with what? That has to do with E. Sorry. E, F, and D. Just address these 3 columns. You can leave these other ones, and then you move on. So when you get your variance, whatever the value is, whatever your variance is, you will then have to now use it. You apply this now. You apply probability of X. If I am saying that it should be 18 hours less than equal to 18 hours. That's what you are looking for. Okay, so now you come down here, you add up all of this, so add this up. I don't know what this is going to give you because I've not done it. You add this up, whatever you get, you hold it down. You also add what you have here, is your variance. Whatever you get, you hold it down. Okay, you look for the standard deviation of this. Now, at the end of the day, you have this formula, x minus this divided by your standard deviation. Okay, so but for now, I'm going to stop here. When I come to class, like I said, I will pick it up from here. For now, what you have to focus on, just leave this other aspect, because I know it's a little bit deeper, but it's not that difficult. Leave this other aspect. My interest for you is to fill up this, fill this up, practice this, fill it up, and then practice whatever we have done here and get the actual orientation. Be very careful about going back. That going back is usually the issue. So with that, we are good to go. So the last, yes, please. You have I have 5 minutes more.
This critical part that you indicated here.
Yes.
What are we doing to this three part? You said the last. No.
This one.
Scroll up, sir. Okay. No. Scroll up, sir. Like the first question we there this place.
Yes.
You said this last one is the longest, is the most critical part.
Yes.
Is it just that last one we are meant to deal with?
Sometimes you want to see, they may say look for the parts that leads to the end of the project. Like I said, this one is one part, this is another part, this is another part. But which one is the critical part? This one is the critical part because it's the longest part. Okay, we have different parts, but the critical part is the longest part that tells you when we expect the project to get completed. By the time you add up all the duration within this one, this longest one, it will end up to 41. But the other ones will not be up to 41, so they are not critical.
Okay, but when they say identify the critical part, it is just this last one we are meant to.
You can do it that way too. Yes, depending on how the question is presented, you can be asked to identify the parts, then also the critical parts. We just want to see how you can trace. You can really look at the diagram and see how the arrows move. That's just it. But however, most likely it's just critical parts that you might be asked. Most likely. Is that okay?
Then one more thing, sir. When you were explaining the formula, I did not really get it.
Which of the formulas now?
Both this and the part, the CPM and the part formula, sir.
For the CPM, the formula for CPM. Okay, you mean the total float? Is clear now. Look at it here. By the time I give you the document, you will see it. It's very clear. That's what I have here. This. I only try to show you how I do it personally. Total float is LFT minus EST minus duration. And then free float is EFT minus EST minus duration. Independent float is EFT minus LST minus duration. And I explain what all of them is here, or what they are. But I want to believe when you go through the material, you will get it better.
Okay, sir. Okay, sir.
Any other question, please? Okay, in that case, I will call